Hello there, I'm Linus from Gravitee. In this video series, we'll be looking at the agent-to-agent protocol. We'll be looking at the challenges that existed that the A2A protocol looks to address. We'll then talk about what A2A brings to the table and how it solves those problems for agentic communication. And then we'll discuss why enterprises need to look at an agent gateway for proper implementation in the enterprise for agent-to-agent communication. Now, in previous videos, we looked at autonomous agents and how they converse and interact with LLMs as their brain and MCP servers through their MCP clients to invoke different tools and systems to give context to the LLM and to take actions on behalf of the LLM. Now, that solves a lot of problems. But what about one of the tools that you need to invoke is not an API, it's not a database, but it's in fact another agent infrastructure, an agent system. So let's say you imagine you have a prompt coming from the user to the agent to book a hotel or book a flight. Well, maybe there's enough tools provided by the MCP servers that the agent and LLM can solve that problem and give a response back to the user. But what if this is a concierge agent that do not have access to the actual hotel or flight booking systems? Well, maybe then that agent needs to invoke other agents. So let's say that another agent developer has built, let's call this one agent 2. So maybe that agent is purposely built for handling conversations with hotel systems. And then maybe there's another agent built by another team or another developer, which we're going to call agent 3 here, which maybe is used to book flights. So on its own, it might have LLM software that it's invoking, and it might have different MCP server that is invoking. Maybe that proxies different REST APIs or database systems to make those bookings and inquiries. So how do I achieve this? How can this agent interact with another agent? Well, first of all, agent 2 and agent 3 need to somehow expose themselves, either within the network or through the public infrastructure. So they need to make themselves available. They need, of course, also to implement some sort of authentication so that the first agent has the ability to implement that. It then somehow need to make available what it actually does. So it needs to have some sort of registry or some sort of list of skills or capabilities that it can handle. So you have to implement all that logic in your different agents. You need to expose some type of server with some type of protocol. You need then to have some sort of authentication and authorization and some sort of registry that you can give to the first agent so it knows how to invoke it. Then, of course, this agent needs to have a developer building out the actual client logic. So you need to build some sort of client logic here to allow this agent to invoke these, let's use this pen, to use these other AI agents right here. And the challenge here, of course, is this might be using one type of protocol, and this here might be using another type of protocol. And the actual type of definitions here might be completely different. And not only might the authentication be different across those agents, it might also be that how they're describing their skills might be different. So there's a lot of complexity that you need to take into consideration to implement something like this. Now, there are bespoke systems like Crew AI, for example, that are focused on this sort of inter-agent communication. But what if you have agents in different departments or using different systems? For example, maybe this agent here is running on something like Amazon Bedrock, and the agent that I built over here, maybe that one is running on LangChain. So they might be running on different types of frameworks, different type of systems. Maybe this here is running on Google Vertex AI, for example. So this is another big challenge. You have different protocols, different type of authentication, different types of way to describe the skills that these agents have. And they might be running on completely different network, different platforms, different frameworks. And those are some of the challenges that A2A looks to address. Okay, let's put a check mark in before A2A, as we now looked at some of the challenges that has existed for multi-agent communication. So we have the scenario still. We have an agent that is getting a prompt from a user to achieve a task. For example, booking a hotel, which might not be in the vocabulary of our MCP capability connected to that agent. And it may need to invoke another agent purposely built for helping with hotel and reservations and flights and so forth. That is delivered by agent 2 here running on Bedrock and agent 3 here running on Google Vertex. So what is a better way with A2A, the agent-to-agent protocol, to solve this? Well, with A2A, you're standardizing the communication between the agents using a consistent protocol and sequence. So the first thing that happens is the agent 2 and agent 3 gets implemented what are called A2A servers. So that is a standard implementation of the A2A protocol that basically enables the agent to be exposed and invoked over the A2A protocol. And most modern agent frameworks and platforms supports the A2A server capability within the agents. The other thing we have to do is we have to make sure that our agent here has an A2A client that is implemented within the framework or platform, which thankfully platforms like LangChain provide A2A client reference implementations. So now the A2A client can communicate with these different A2A servers without having to care or know about whether this agent is running on Bedrock or this agent over here is running on Vertex. It's a consistent protocol. That protocol, by the way, is using the HTTP specification. Can also use server-sent events for asynchronous communication. It's using JSON RPC as the actual data format of the data that is flowing through those agents. So just as with MCP, the first thing that the client or the host here needs to do is to provide a definition of not the tools, but the skills that these agents provide. So A2A has something called agent cards. So the first thing that happens is the A2A client that are registered pointing to those A2A servers will effectively get a list of agent cards. So I'm going to put here agent cards and agent cards over here. So those are effectively sends over to the A2A client. The A2A client then gives that through the agent to the LLM, just as it would do with an MCP tool. So from the LLM perspective, it's now super easy to understand the sort of skills and capabilities that those other agents as part of this network now have access to. So just as with MCP gives a standard definition to the LLM in terms of what skills are available without having to care about different types of implementation of agent definitions and skills. So that's the first thing that happens. The agent card includes things like skill, which is effectively equivalent to a tool. This determines and talks about what the agent do, for example, booking hotels, booking flights. The second thing it talks about is capabilities. So that's more of the nature of that particular agent belonging to the agent card. Maybe it is support streaming for service and event, streaming between the client and server. Maybe it talks about the particular authentication that the particular agent supports, so that the A2A client can adopt based on the different A2A servers it is communicating with. So now what you have is you solved it for the agent developer, not having to implement multiple protocols to invoke multiple agent platforms and frameworks. And you've given a consistent way using this agent card format to discover agents in your network that your client is registered to over those servers. And you're giving a consistent model and definition to the LLM to understand. Now, the next thing that you're solving is when the LLM tells the agent, hey, I want you to invoke this particular skill. I want you to use this agent. The LLM might not necessarily know that it's an agent. For the LLM, it comes across as a tool. But the agent knows that this is not an MCP server I have to go and invoke here. It's an A2A server. So what happens is the A2A client makes communication to one of these two agents or multiple, depending on the action. And that is what is called a task or a message. depending on the nature of that invocation. So that's a consistent JSON RPC way of invoking and sending payloads from this client to the server. Now, of course, you might then in the future go and have another infrastructure where these agents also have clients that are talking to each other, just as you had with your LangChain agent. But that effectively is the A2A protocol and how it solves for the inter-agent or multi-agent systems without having to worry about what protocol, what framework, what language the agent is implemented in. All right, let's put a check mark in with A2A as we now explore the A2A specification and protocol and how it solves some of those multi-agent interaction problems. But is that enough, or does that bring enterprise challenges just as an MCP implementation do? Yes. So with more agent interaction comes more challenges. You'll have multiple agents talking to each other, and you need to ensure you have the observability and consistent security and rate limiting and access control in place. So one approach to solve that, just as with MCP and LLM, is by implementing a gateway proxy in front. So that's where you encounter the agent gateway, whether that is for A2A or other agent standards that are less adopted, such as ACP or something from agency. So the concept of an agent gateway is to implement the A2A client and server protocol itself so that A2A clients can invoke them, and then the agent gateway can route to the various A2A server implementations. Now, it's important that the agent gateway do implement the A2A client and server protocol, because one of the things it needs to do is needs to be able to provide the agent that JSON cards back to the client. And as part of the agent cards, you have the URL that points to the actual A2A server. So that needs to be rewritten after traffic goes through the agent gateway. So what are some of the benefits that the agent gateway brings to the table? Well, first and foremost, just as with the MCP, you get consistent authentication and authorization by having this proxy layer in between. Whether your organization is using OAuth or JWT or MTLS or a combination, having an agent gateway allows that gateway to work with one identity provider and ensure consistency in how your agents and maybe delegated through humans interact with other agents. Another important thing, just as with for both LLM and MCP utilization, is the ability to enforce rate limits and quotas. Maybe the agent on Bedrock, for example, is very costly and sensitive and should only be used 5 times per minute by this concierge agent, for example. Also, what is important is the ability to have granular skill access. So we spoke previously about granular tool access for MCP. It's very, very similar here for the A2A protocol, where maybe my hotel booking agent is also able to provide reservation information or to send out invoice to clients. And those are not skills that I want my concierge agent to have as part of its subscription to that agent. So have the ability to filter across all the agents the actual skills that it should have available for different agents for different use cases is quite important. Now, not only controlling which skills people have access to, also going down to the data level for data filtering or masking could be very important if your agents are exposing data from LLMs that you don't necessarily want other agents to have access to. So having an agent gateway in between really helps with that challenge. Now, one capability of an agent gateway is also abstracting away the agent implementations from the clients. So without an agent gateway, your different A2A clients would have to keep a reference, a URL to each of those other servers, which can get very, very messy if you're starting to have other agents talking to each other with their clients and servers. So instead, having them go through that one router, one gateway really helps with that agent discovery and agent sort of routing capabilities. Speaking of agent routing and observability itself is very important when you're building these sort of systems. Not only do you want to understand what skills of my agents are being used the most, what are some of the most popular ones when you build, let's say, agent products to the rest of the organization, or outside of your business to your customers and partners. It's also important, of course, to understand the performance, the analytics available into terms of how much utilized an agent is, which might have an impact on your on the cost, because you might have MCP and LLMs that are part of those other agents, which in themselves have costs associated with them. Okay, so let's put a check mark in the last box here, where we've looked at how an agent gateway can be used to help gain control, security, and routing and observability in multi-agent systems on top of protocols like the A2A. Thank you so much for watching. I look forward to the next video series.